The stakeholders give us a feel for what the system's supposed to be, but capturing the requirements is a critical task to basically get that feedback. We not only want to write down what they're saying so we have it for later, but also so we can confirm it with them and share it with all the different members on the team. So capturing the requirement has some general steps we want to do. So the first thing is problem recognition. We need to know what the problem is we're trying to solve. Those conversations with the stakeholders give us a feel for it, but we want to make sure we get that confirmation of what problem are we trying to solve. Do you have a problem with payment timeliness? Do you have a problem with as opposed to, it's a payment, maybe the amount of payment. So maybe what I want to do is minimize the amount of payment. So I don't want to do credit card processing where I'm having to pay extra. But maybe the flip side of it is maybe people don't pay their bills. So maybe paying the extra for credit card processing is exactly what I want because it's solving my problem with payment timeliness. So those sorts of trade-offs. What problem am I solving? From there, we'll talk about how do I evaluate and synthesize a solution. It's not doing the whole solution, but the type of approach, the type of thing that would be acceptable. We're not going to get every level of detail, but we want to capture at a high level what type of approach can we take. We want to ideally do some modeling of the data that we have and the approach that we can take to solve this to, again, get a feel for what's missing and what we might need to do. Then we're going to get to the point of formal specification that we just talked about. We're going to formally capture the stuff, write it down, and review it all. There's going to be a lot of different parties we want to review it with, so we want to make sure that we have it documented in a way that's easy to transmit and record and be able to get feedback on. So problem recognition, as we said, is really trying to figure out what the thing that needs to be fixed. Sometimes as developers, we fall into this solution of software solves everything. And I can tell you, in the last 6 months, there's been more times that I recommend not building software than I have building software. It's easy to get in the habit of, oh, you have a problem? Let me fix it. As the saying goes, when you have a hammer in your hand, the whole world starts to look like a nail. And if you try and hammer in a screw, it's going to cause more problems than it's going to solve right there, for instance. So sometimes you got to stop and say, hey, is there some way we can solve this better with a change in process, with a change in hardware, with a change in the way the users use the system? But then if it comes down to it, let's make sure our software is solving the problem that's needed. And so I'm going to take that problem and I'm going to evaluate it further. I want to do some analysis of the environment. I'm going to make sure that the way I've identified the problem makes sense and it's something that can be solved. I want to better understand the system and how my product's going to solve the problem. So for instance, we talked about a payment system. How am I going to get that out there? Once I start doing payments and credit cards, I have to deal with secure portals. Am I just going to go get my own certificate? Am I going to use some sort of open vendor? Am I a big company? Am I able to secure my own domain name? We're getting into all things about HTTP versus HTTPS, because these days, if you don't use HTTPS around credit cards, the browser will tell the users, don't go use this site. It's unsafe. Get away from here. It's a bad thing. You want to be able to make sure you understand the role you're willing to play in the system. And basically starting to parse out how you can solve the problem. So in order to do that, I have to find ways of capturing data. The key to recognizing the correct problem, evaluating it, and then synthesizing a solution is communication with those stakeholders. And we're going to get to the idea of how to do that in later tracks. We're going to be able to talk about that more. There's other classes that talk that. We'll talk a little bit about this class, but there's whole classes focused around requirements elicitation. We don't need to talk about all of that here, but just know that those things exist. This whole class is an overview of process. We can't talk about everything in every bit of detail in the 5 weeks we have. But one of the things that's not captured very well individually very often, but as a tool you should consider, is the idea of modeling. So we'll talk a little bit about object-oriented analysis and design. We'll talk about structure analysis and design. You might even take a class on using design techniques, but we want to use those techniques all the time. In my career, I found that I constantly think in terms of how I model things, whether it's modeling databases or modeling networks or modeling software through object orientation. That's the tool I prefer to use. If I can get that early look at the system, it allows me to capture a picture of the system, a simplification of the system, and be able to share those ideas with others around me, and then evaluate my own thinking in much better. So what is a model then? So traditionally, a model is a scaled down version of a real thing. If I'm talking about a train model, you have a really big train out there somewhere in the world, and then I have a 1/10 size of the train, or 1/8 size of the train, or whatever it's going to be. The paradigm really doesn't fit the software so much. Software, there's no physical size to it. It's all virtual. But what it is, it's a smaller version of all the data that exists in this real world. So in a model in the software world, I'm going to have some level of information that I'm trying to describe. I have data that's in the system that I'm going to try and capture. And then I have functionality that I want to describe, which are the things my system wants to do, and then behaviors, which is response to events. The idea behind this is, as I'm capturing these things, I'm not capturing everything the whole world does. I'm just capturing the things my system does in response to the whole world. So yes, users can come in and do all sorts of things in customer service, but my customer service app might only simply allow me to buy, return, or redirect shipments. If they have some sort of problem with their login, my customer service application might not have the ability to fix that. I actually worked at the company one time. If somebody forgot their username, they were supposed to use their security question. If they forgot their security question, the only way to fix it was to create a ticket to have a developer go into the database and manually update their password and security question, have them reset that later on. They didn't build that functionality. It was a big oversight because the model didn't anticipate the need of that. It's not to say it was an oversight entirely, but the model helps us see, well, how would somebody do this? The idea of a model is it's supposed to enhance how we look at the system and the completeness of our requirements. That's the value of doing this modeling earlier than traditionally you might think. It's because by looking at the model, looking at these features, looking at these behaviors, I can start to see more than the words on the page. There's less focusing on grammar and text and more focusing on the system and the behaviors that are out there. The model's easier to look at. It's a picture. I can review it for, often it's a picture. I can review it for completeness and accuracy that I might lose reading pages and pages of text. And then it gives us a good foundation for moving into design. So modeling is a great way to capture a lot of detail without a lot of space that I can come to later on. And so specific techniques on modeling is not something we're going to talk about now. We are going to do a little bit of discussion on it. You're going to get into it in other sections of this class when we go into design next week. And there's, as I said, other classes on this stuff entirely. But we'll talk a little bit about structure analysis and object-oriented analysis and the ways we can use those to capture our model. Now, that being said, the model is not the requirements. We still need to get to the requirements in the form of the specification. The specification then is the text version. And there's many different ways we can capture this text version. We're going to talk about that as we go forward. But the text version is basically the details of what do we want. It might be extremely big details. When I worked on the airplane application, we had 27,000 individual requirements that were captured. There was no printout of that. They were all electronic because printing it out would have been massive, massive book. But I'm sure somebody printed it out. I didn't print it out. But the system needs to be defined, in terms of this very contractual. So we know exactly what's going to be the behavior. We know how we're going to test that behavior. And essentially, in many cases, it is a contract for services to be rendered. It has to be built and released and delivered that way, particularly when consultants are involved. Sometimes it's less formal. Sometimes it's just an agreement between friends. But that's specification. The specification then is the details of what is my system going to do that I'm going to start to write down. Now, I might not write it down super formally. I might just be capturing some notes, but it's something that really needs to be understood, at least within my team. What are the developers going to build? What are the testers going to test? I need to at least capture that much that we know it's going to be done. And the way I capture this done is going to vary. It's basically, I start to write down some statements like the system should do this, or the user will click on this screen and see this sort of thing. But sometimes we need more than that. Sometimes we need to know exactly how it's going to be built, and that's where we get into formal specifications. A formal specification is going to be a formal document with a very well-known structure that's going to allow essentially contractual level language inside of there. That it's going to be very clear what the user's going to get, what functionality they're going to see, what it's going to be tested by. It's going to be very testable requirements inside of there. It's going to be very clear. Not the font should not be very big. No, it should say something like the font shall be no smaller than 12 times Roman. I mean, that's very, very testable at that point. Not very big. It's very vague. That's fine among friends, but at some point you might get to the point of having contractors inside of there. You might have to get to the point of hammering out whose fault it was if it's wrong because there's contracts and money involved. It's not ideal, but it does happen from time to time. So the formal specification gets us down to where we need to be. Now from here, we need to do some of this. So our next couple videos here are going to take us into some activities that's going to get us prepared for and ready to do the types of things you're going to be asked to do in the individual project.